8.4c, let's start with a quick review. What does bisect mean to do? When you bisect thing, we cut into two equal halves. And what is a ray? Remember, if we had ray, we write it with one end and then an arrow at the other. It's a kind of part of a line, and it goes in one direction. Kind of like a flashlight. It starts at a point and it goes in one direction. Next, our triangle angle bisector is what we're going to talk about today. Is theorem is if a ray bisects any angle and divides it the opposite sides into segments whose lengths are proportional to the lengths of the two other sides. So what does this mean? So let's say we had this ray here, CD. It's bisecting this angle ACB, into two equal halves. Well, the proportions are here. The first top and the bottom half. And we can say that our proportion AD, the part of the purple, over, well, let's make this purple just to really home it in. AD over DB is proportional to CA over CB. So notice that AD is the segment that is on the flat side of the triangle, and CA is one of the legs of the triangle. Things we need to see to use this. First, we need to see the ray. We need the ray CD. Notice there's an arrow here at the end that indicates it's going on forever. We need to see a ray, and we also need to see two tick marks to indicate bisect. So here, this and this indicate bisect, and we needed to see that to indicate bisect. So here, just like this. So let's try out some of this today. Let's label this. So let's say this is SNOW. Our setup, NO over OW, so the flat side, is equal to SN over Y, or SW. Substitute that in, so we have 4 over 6 must equal 8 over Y. We're going to cross multiply, so that gives us 4Y equals 48. Divide by 4. Divide by 4. Y must then equal 12. Okay, let's do another one. Let's say this is COLD. Our setup would be OL over LD is equal to CO over CD. Substitute those in. Z, I'm going to call the Z, equals 3. LD is 1.5. 3 CD is 4.5. We'll cross multiply that like so. That gives us 4.5Z equals 4.5. Will we divide both sides by 4.5? Z must equal 1. All right, let's try out some other ones. Keeping on with our theorem, like so. We'll set this up just like as always. Well, these are labeled, so we don't have to label these. So our setup YZ over ZX is equal to wy over wx. Plug in the numbers. 4 over 4 must equal 4 root 2 over y. But let's not get intimidated by these letters. We just got to cross multiply. 4y must equal 16 root 2. If we divide both sides by 4, we only need to divide the 16 by the 4. So y is 16 divided by 4 is 4. So this is actually 4 root 2. Next one, we took over number 2 a little bit, but I'll write smaller. Here, our setup, we'll skip the setup for now, but we can plug it in. Notice this is 15, the whole thing. So this part here is actually 15 minus x. So we can set this up. So 15 minus x over this part rs, which is it's equal to 7. 15 minus x over this part, and 7 over 13. We'll cross multiply. That gives us 13 times 15 minus x equals 7x. Distribute 195 minus 13x equals 7x. I'm going to add 13 to both sides. 195 equals 20x. If I divide both sides by 20, x equals 9.75. Okay, and our very last one, set this up here. SU, or ST over TU, is equal to SV over VU. Substitute. That gives us 14 over x equals 24 over 48. We'll cross multiply. Cross multiply, we get 672 equals 24x. Divide both sides by 24. X then equals 28. We're not done because they don't want us to find x. They want us to find SU and TU. So I'm going to plug that back in. So here, this part TU equals what? 28, because it's x. So that we have. Now SU is the entire distance. So SU equals 14 plus 28. SU must end up equal 42. And that is it.